Okay, so wrapping it up with open source software. So in the early years, it was no, as I mentioned, independent software industry. Well into the 60s, software distributions included the actual source code with it. And then in the 70s, organizations recognized the increasing value of the software source code. So most companies decided to make their programs proprietary. And today, companies develop proprietary software and it's tightly controlled in its distribution. So, by treating source code as a trade secret and distributing only the object code, which is not in human readable form, is what's happening today. So, when people purchase a program, they're actually buying a license to allow them to run the object code in this non-human readable form. So there are criticisms, of course. Governments have given ownership rights to those who produce computer software because of the perceived benefits that they will get, right? The assumption is that people will work harder and be more creative if they must compete. And while most people point to the benefits, some have noticed the harms, right? Here's an open source definition, right? No restrictions, no restrictions, no restrictions. Same rights apply to everyone receiving distributions, right? The beneficial consequences listed here, I think we've kind of gone through that. Then there are examples of open source software, right? This movement is the philosophical position that source code software ought to be freely distributed and that people should be encouraged to examine and improve each other's codes. It's a faster loop. So in IT, right? It's going to promote a cooperative model of software development. Open source is an alternative way of distributing software too. Licenses do have some common characteristics, right? But note that there's nothing in the licensing in those guidelines that says that open source programs has to be given away free, right? The company has a right to sell open source programs. However, the company can't stop others from selling it too. Bind provides DNS, domain name service for the entire internet. So some of it's quite famous. Apache runs about half the world's web servers. Chrome is the world's most popular web browser, along with Firefox, I think is number 3, the book said. And those are huge open source capabilities. And programming languages like Python and Zope, etc., are open source, right? So the open source initiative at opensource.org, it's a non-profit corporation, and it promotes a common definition of open source. And it says basically there are these multiple beneficial consequences, right? Like giving everyone using the program the opportunity to improve it. That people actually get to fix bugs and add enhancements or adapt that wouldn't otherwise be made at least as quickly. That new versions, in fact, speaking of quickly, new versions appear more frequently, and it eliminates this tension between obeying copyright laws or helping others. And an example of that is the GNU project. With Linux. GNU project and Linux are important success stories in the history of open source management, right? So GNU project started back in 94, and it developed a complete Unix-like operating system, right? There are many operating systems, Unix being another one, but consisting entirely of open source software. And so in order to be fully functional, modern operating systems include now text editors, command processors, assemblers, compilers, debuggers, device drivers, mail servers, and many other programs, right, that were being incorporated. So in 1991, Linus Torvalds began to work on a Unix-like kernel, Kernel, that he named Linux. Right? The kernel, as you recall, is the software at the very heart of the operating system. And so what we have is a complete open source Unix-like operating system. And Linux has become commonly accepted name for open source operating systems based on the Linux kernel. And so a world-class operating system coalesced as if out of magic, right, from these part-time hackers or by several thousand developers scattered all over the planet, connected only by the internet. So Linux has become a viable alternative to proprietary versions of Unix. And so, in fact, 97%, it says on the slide, of the world's 500 fastest supercomputers are running the Linux operating system. And then the last thing to touch on today, as we saw earlier in this chapter, some believe strong intellectual property protection stimulates creativity by dangling the prospect of financial reward, right? And so others believe, however, that creativity is suppressed and that information technology has created an environment in which an unprecedented amount of creativity could be really unleashed that is not. So their concept would be we're standing on the shoulders of our peers. And it's all about the internet, right? That's what it's all about since the beginning, this open source, architecturally open approach, right? So strong intellectual property protection, many would feel, stands in the way. An example, for example, public streets, parks, beaches, the theory of relativity, the works of Shakespeare, right? This is those creative things that should be let free, right, for everyone to use. And the internet forms a sort of innovation common, right? Because its control is decentralized, right? One person can be introducing a new application or a new content without getting anyone else's permission. So with a Creative Commons license, you can retain the copyright while allowing some users of your IP to use it under certain circumstances. So commercial artists may choose a Creative Commons license to increase exposure to their work if they're new, right? It can be used for non-commercial purposes as long as the user gives you credit. And computer-readable versions of the licenses are designed to make it easier for search engines to identify that kind of content. So there you go. That was a great time this week. I hope you enjoyed it. I know I did, and I look forward to next week. Thank you.